Okay, so good morning to everyone. Now, today we will start about the topic that is the name as cache coherence problem. So, first starting that, we will know what is coherence. Now, basically, coherence means it is the property of the shared memory architecture. Now, if you remember, the shared memory architecture is related to the multiprocessor. Because in the multiprocessor there will be the multiple processor present and all of them will share the shared memory. So memory will be there and all of them share that memory. So that's why it named as the shared memory. So it is the property of that shared memory architecture in the multiprocessor that it gives the illusion to the software that there is a single copy of every memory location even if a multiple copy exists. Now, what is the problem? If you remember, there is the processor present. So, multiple processor will be present there. There is the multiple processor. Like in this example, you see P1, P2 to Pn. So, n number of processor are present. And each processor has its own local cache. Each processor has its own local cache. So, processor 1 has cache C1, processor 2 has cache C2, processor N has cache Cn. And all of them are doing what? All of them are sharing the same memory. So they are using the same memory. Now let's say there is a value in the shared memory that is x. Let's say there is a shared in this value, there is a x. Now all of the processor cache will able to access this shared memory because this memory is shared between all the processor. So that means all of the processor can able to access this memory. So this x will be present in each of the cache because processor has its own local cache. So it will do what? It will store the data from the shared memory to the processor's own cache. So from shared memory, the data x will be stored in cache memory 1, cache memory 2, cache memory n. All of them will contain the value x because they are sharing the same memory. So all of them will contain the value x. Now the problem happens, let's say processor is stored in its own local cache, the data it is stored and the value here is x. Now let's say happen that processor performs some operations and after performing the operation processor do what? Processor changes that value x to x dash. Let's say processor after doing some operation, it changes the value as x dash. Now the inconsistency will happen because all of the processor will do what? All of the processor are accessing with this local cache they have present and all of them are sharing the same memory. So that means this x will be contained by all of the cache. All of the processor's cache will contain the x value. But some reason after doing operation, this processor 1 changes its cache that as the x dash. So that means only processor 1 cache will contain the x dash, but other processor cache will contain the value x. This is the inconsistency because if it should be consistent, then all of the processor cache will contain x because through a bus they are accessing the same memory. So why there will be all of the cache memory will contain the value x because they are using a bus and with this bus they are accessing the memory. So then all of them will contain the same value. But here the processor one does what? It changes the value by doing some operation. It changes the value to x dash and this x dash it will store in its own cache. But the other cache will contain the value xc only. So this is the problem. So that's why it is said that if this x data is shared by each and every processor cache, means that x data can be copied in C1, C2, and Cn. That means all the processor will contain the data X. The data X will contain all the processor. Now, if we give permission to any processor that it can change the shared copy independently, then the particular cache contain the updated data X dash. That is, if we give some permission that okay, you can do your operation and can change the value as X to X dash, then only this X dash will be reflected to this processor cache only, but the other processor cache will contain the previous value, that is X. This is mainly we call as the cache coherence problem, because since multiple copies of the same data can exist, multiple copies of the same data can exist in different caches simultaneously, and if the processor is allowed to update their own copies freely, an inconsistent view of memory can result, and inconsistent view of the memory will be result. Now, inconsistent memory of the same memory block in different caches. Now, cache inconsistency, it is a problem. That's why the cache inconsistency occurred. But basically, for some reason, this cache inconsistency happened. Now, what are the reasons this cache inconsistency occurred? There are three types of problem. That's why this cache inconsistency occurred. First is the data sharing, second is the process migration, and third is the IO activities. Now, the first type, inconsistency due to the data sharing. What happened there? Now, let's say we have a like this the processor present, and we know that each processor has its own cache memory. Like P1 is a processor and P2 is the processor we are taking, this two processor, and this two processor has its own local cache. So P1 has this cache and P2 has this cache memory, and through bus, this is the bus, through bus they are accessing the same memory. Now the memory is single, and in that memory, let's say there the value stored is X. Now both of the cache, both of the processor will use the cache, and with this cache they are accessing the same memory. So that means in the memory, whatever this value is stored, let's say in memory the value is stored as X. So that means this X will be reflected in this cache also, this X will reflected in this cache also, because both of them are accessing the same memory. So it is the thing that it happened. Now it is that before the update of the X consistent, that means all the processor has what? All the processor has in its local cache the X value is stored, because they are accessing the same memory, and in that memory the value stored as X. So that X is reflected in each of the cache. Now, second is write through cache. Now, what happened? Let's say after that, the P1 processor does what? P1 processor makes some operation. P1 processor have done some operation, and that operation do what? Using that operation, it makes the change the value as X to X dash. It changes the value as X to X dash. This is what after changing, because in it here the X value is previously stored, but after doing some operation, let's say this X value is changed as X dash. Now this processor with this cache, they are accessing the memory. So that means this X dash will be changed in the main memory also, because in the write through cache policy, cache and main memory are updated with every write operation. Now it perform the write operations on the cache, and when this write operation performed, this X become X dash in this cache, and that when this will be updated in the main memory, it is also be reflected. So in the main memory it is reflected, and in main memory the value is updated as x dash. But this processor is what? This processor doesn't do any operation now, so it will contain the previous value as x. Now that you see, they are accessing the same memory, but here the value is what? The previous value this cache is containing. So that means it is the inconsistency, because this cache is done its operation, and after doing the operation it changes the x to x dash, and it is reflected in the main memory, because through bus they are accessing it. So it is reflected in the main memory, and in the main memory also the x become x dash. But this processor doesn't perform any operation, so that's why the previous value is already stored in its cache. That is x, that previous value is stored. So that means this main memory, the value is different, and this cache contains the different value. So this is the problem. This is the inconsistency. Inconsistency occurred in the using the data sharing, and this is the write through cache. Now write through cache, what happens when the cache and main memory are updated with every write operation? This is the write operation, that x become x dash. So when this write operations will perform, then cache as well as main memory will be updated after each write operation. So we see that write through cache, this inconsistency is occurred. Next is the write back cache. Now in the write back cache, what happens? Only cache is updated and the location is marked. Here the cache will be updated and the location will be marked so that it can be copied later into the main memory. Means later it can be copied into the main memory. Now if the data in the cache is deleted or replaced, then the main memory data is updated. Now let's say in the write back cache, what happens? The same process, that in its sorry, in its cache there is x value previously stored, because they are accessing the same memory. Now this processor performs the write operation and makes this x to x dash. It updates the cache and marked that location, because in the write through cache we have seen that cache as well as the main memory will be updated when any write operations will be performed. But here in the write back cache, what happens? Only cache memory is updated and it is location is marked so that it can be copied later on to the main memory. So only x dash will be updated in the cache memory, but it will not be reflected in the main memory. Yes, it will be reflected, but later on. Now when later on this will happen, the x dash will be there, the x dash will be reflected there when the data in the cache is deleted. When the data in the cache we will delete or replaced, then only the main memory data will be updated. Then only it will become x dash. But now it will only contain x. So here also you see one processor cache is containing x dash, but this processor cache the value is x, and the main memory also contains the value of x, but only this processor has in the cache, in its local cache, x dash value. So that means this is also an inconsistency, because each processor cache will contain x value. That is the thing, that all of the processor and main memory contain the same value, but here you see this processor is containing the different value, because after performing the write operation it is updated. So that's why it does what? It contains the x dash value. But in the main memory, the previous value is there present. So this is the problem of the inconsistency. And this inconsistency is what? This inconsistency happening during the data sharing. So by data sharing, this problem happens. And the two types are the write through cache and write back cache. Okay. Clear? समझ में आया?
Yes, sir.
So this is the first type of a problem, that is we know as the inconsistency in data sharing. Okay, so that is written that write policies, that what we have discussed, that write through, if the write through cache problem happens, that means cache and the main memory will be updated with every write operation. But for the write back, what happened? Only cache will be updated and the location is marked so that it can be copied later on into the main memory. And if the data in the cache is deleted or replaced, then only in the main memory data will be updated. The main memory data will be updated only then. Now consider a multiprocessor with two processors each using a private cache and both sharing the main memory. Let X be a shared data element which has been referenced by both the processor. Now before update, 3 copies of X are inconsistent. Three copies are consistent. That means in the first, we have seen that before updation, all of the processors, local cache and main memory contain the same value. That means all of them are containing the X. But problem happens start when it uses the write through cache, and when it write back cache, this problem is happened in that time. So this is the inconsistency occurred in the data sharing. Now the second type is the inconsistency occurred due to the process migration. So let's say in the write through policy, if processor P1 writes new data X dash into the cache, then the same copy will return immediately into the shared memory using the write through policy. So cache write through policy is what? When the cache will be updated, in that particular time, the main memory will also get updated. So in the case of inconsistency occurred between the two copies X dash and X in the two caches, that means inconsistency happened between the caches data, because if one processor performs operation over its own cache, then it will done, it will do what? It will move X to X dash, it will move X to X dash, and this will be reflected in the main memory also. But in the other processor, it not performs any operation, so it will contain the previous value, that will be X. So this will happen during the write through policy. But write back policy is what? Only the cache will be updated during write operation, but the main memory will not update. Yes, main memory will be updated, but when the cache will be deleted, the value that is stored in the cache will be deleted or replaced. In that time only, the main memory value will be updated. So here what happens? Inconsistency will occur between the value in the cache and the value in the main memory. There the problem will be happened. Now the second type will be what? The second type is the inconsistency due to the process migration. Inconsistency occurred due to the process migration. Now here also we are taking that, let's say there is a processor 1 present, and this processor 1 has a cache, and this cache is containing the value X. The value X this cache is containing, because in the main memory, the value stored is as the X. The value stored it's as the X. And this P2 is the another processor, and its cache there is no value, because P1 P2 till now doesn't access the value X. So that's why this value is not updated into its cache. That's why in the cache it is empty. For P2 the cache is empty. Now first what will happen? The process migration. The process migration means from this cache the value will go there. That is, first in the above figure show the inconsistency after the process containing the shared variable x migrates from the processor 1 to processor 2 using the write back cache. That means what? Let's say this x, the cache content, this is migrated in the processor 2's cache, and after going there, after migrating there, what happens? This processor 1 performs operation over its own cache and make the value from x to x dash. Now after making that value from x to x dash, what will happen? Write back. So write back means cache will be updated only, but main memory value will not updated in this meantime. So what will happen? This will happen that in the processor 1, the value after write operation, it will contain x dash, and the processor 2 is what? It will contain the value x only, and in the main memory also the value will be as it is like x. So from process migration, what happens? From the cache 1, the value or the process is migrated to the processor 2's cache. So from here the value x goes to the processor 2's cache. So processor 2's cache will contain x now, and after that processor 1 does what? It doing the write operation over that value and make that from x to x dash. So that means it will contain now x dash, processor 1's cache. But processor 2's cache, the value is x, and the main memory is what? The main memory, the value is also x in the main memory. So here you see all of the copies should be the same value. All of the copy should contain the same value. That means in the cache, the value should be x, but processor 1's cache, you see, the value is x dash. So that means inconsistency happened. So this is the inconsistency happened due to the write back cache. Okay. So due to the write back cache, the inconsistency happened. Now, in the middle, a process migrates from processor 2 to processor 1. Now, let's say this happened, and after that, what happens? Let's say from this x dash, this processor 2's from processor 1, that happens from processor 2 to processor 1 when write through cache used. Write through cache means what? In the write through cache, the value will be updated. So let's say processor 2 does what? Processor 2 after that performs operation. Processor 2 does the operation, and using that write back, using the write through, it does write operation over that value x and make that value as x1. And in the meantime, the another processor, this we know that process migrates. So first what will happen? The processor 2, this processor 2's value x will be migrated to P1's cache. So that's why in the P1 cache, it is now containing x. And after the process migration, P2 does what? P2 performs a write operation over that x and makes that value x to x dash. Now we are using the write through policy, and we know that if in the write through policy cache is updated, then the main memory value will also be updated. So that's why the main memory value is also updated and it becomes x dash. So here also the inconsistency happened. Now you see they have these two cache have two different values. So this is what, this is also the inconsistency occurred. So this is the inconsistency occurred due to the process migration. So one thing you should have to keep in mind, that write back and write through. Write through means when the value will be updated, that value will be updated both in cache and main memory. But when the write back cache technique is used, in that case the value only in the cache will be updated, but not in the main memory the value will be updated. Yes, the value will be updated, but later on. When the value will be updated in the main memory, when the value is not present, or we can say the value that present in the cache is replaced or deleted, in that case only the value will be updated into the main memory. But in other cases, it will not happen. And this is the process migration. This is the process migration problem. Okay, clear? किसी का कोई क्वेश्चन है अभी तक? Anyone has any question?
No, sir.
Okay.
No, sir.
Then last type is the inconsistency occurred due to the input output operation. Inconsistency occurring due to the input output operation. Now what this means? Here you see in each processor we are using this processor 1 and processor 2. Now processor 1 has X in the value, in this X is the value stored in the cache, because the main memory is there and this main memory has value X. Same as that processor 2 has also what? Processor 2 has the value X stored into its cache, because they are accessing the same memory. So both of them will contain the value X in its own local cache. And there is another input output device we are taking. There is another input output device present. Now first we will see the write through cache. In the write through cache you will see, then first IO operations will be passing the cache when input output processor loads a new data X dash into the main memory. When a X dash will be loaded, first in the write through cache, what will happen? The input output operations will perform by passing the cache. That is when input output, this is the input output processor. Now input output processor will do what? It will store a new value. It will load a new data, a value that is X dash in it. Now when it will load this new data X dash, then bypassing right through cache, this X data will be loaded into the main memory, Now there is also inconsistency occurring. Now what is the inconsistency occurred now? The inconsistency occurred that in both main memory and in the input output processor, their X dash value is present there, but in the processor's local cache, what is the value present there? X. So that is the inconsistency. Now this inconsistency occurred when the input output processor loads a new data, and when it loads the new data, it is done what? That this X data will migrated and transferred, so that the main memory also updated the X to X dash. So both main memory and the input output processor contain X dash value, but the processor's own local cache, the value is X. So they are inconsistent. This is inconsistency. So that's why this is the first problem that is occurred during the memory input output write through cache. This is the problem that is occurred. And next type is what? Next type will be memory output or the write back cache. Now when this will happen? When outputting a data directly from the shared memory by passing the write back cache also creates the inconsistency, also creates its inconsistency. In that time, what happened? Let's say first we have seen in the memory, the value is X stored. The value will be X stored. And in the processor is what? In the processor also the value is x is stored. In the processor 2 also the value stored is x. This is before the write back. In that time all of them are consistent. Now what happened? This write back cache, the memory, this transfers or bypass directly from the memory to the input output processor. So it process migration happens. So this x data will load into the input output processor now. And in that meantime, the processor one does what? It performs the operation, write operation over the x value and make it as the x dash. Now you see all of them are containing not the same value, because at first both all of them are containing the same value. Then what happened? The memory do what? The memory performs the transfer operation or bypassing operation, and or we can say process migration. So that means this x value will then loaded into the input output processor. And after that, the processor one do what? It performs operation over its local cache data, that is x stored in there, and make that data x to x dash. So all of the processor will what? All of the processor will contain the different values now, because in the cache, one cache it is x dash, another cache it is x. Yes, main memory value and processor input output processor, the value are same, but all of them are not same. They are containing the different values. So this is the problem of the memory output write back, because this x dash will not be now will be loaded into the main memory, because write back, and write back means it will be loaded when this cache will be value will be deleted or replaced. In that time only the value will be x dash, but other than the value will may present xc. So this is the problem, and this happened inconsistency due to the input output operation. Okay, so this is the all type of the cache coherence problem. First we have seen the data sharing, then process migration, and third one is the input output processor. To write anything, you should keep in mind this diagram. The diagram you should be clear, and if the diagram is clear, then you will able to write in your own word. In your own word you can able to write that, because it is not so much difficult. If you remember the diagram, then using first always when you will write this type of questions, write the diagram, draw the diagram, and using that diagram illustrate that description, so it will be clear to you. Okay, it is clear, this
Yes,
cache
sir.
coherence problem.
Yes, sir.
बोलो.
Yes, sir. Clear है.
ठीक है, ठीक. Okay, so this is today. In the next class I will start from the our this cache coherence problem we have completed. Then we will discuss about the MIMD model in the next class, that is tomorrow. Multiple instructions, multiple data. There will be the format, three types of present: UMA, NUMA, COMA, uniform memory access, then consistency memory access. All of this will discussed in the tomorrow's class. And the interface, the IO interface concept we will discuss about that in the next class. Okay, so I will take the attendance of your, so each and everyone please respond. Abhishek Kumar Verma.
Yes, sir.
Okay, Aditya Kumar Pandey.
Yes, sir.
Akash Aman.
Yes, sir.
Amar Arshad.
Yes, sir.
Anamika Choppo.
Yes, sir.
Aniket Singh,
Yes, sir.
Ankit Kumar,
Present, sir.
Amit Kumar Dam.
Present. Present, sir.
Okay. Babita Kumari,
Yes, sir.
Chandni Orea,
Yes, sir.
Jai Prakash Kumar, Jai Prakash, Kajal Kumari, Kajal Kumari, Muskan,
Present, sir.
Nidhi,
Yes, sir.
Pallavi,
Present, sir.
Preeti Kumari Singh,
Present, sir.
Pooja Prantika,
Yes, sir.
Rahil Horo,
Yes, sir.
Ravi Shankar Thakur,
Yes, sir.
Sanjay Pingua, Savitri Kumari,
Yes, sir.
Shivam Kumar,
Yes, sir.
Siram Prasad,
Yes, sir.
Shubhadeep Das,
Yes, sir.
Tamanna Padvi.
Yes, sir.
Okay. So then, thank you everyone.
Sir.
बोलो